Hi there, so let's have a look at this question 6, which is a differential equations question. So we're asked to obtain the general solution of the equation given here, and we're told it's between x is between 0 and pi, and we're asked to give our answer in the form y equals f of x. The highest order derivative we've got in there is the first. This is a first order differential equation. We've got dy dx plus some function of x times y. So this is looking like it's going to be a linear one that we're using our integrating factor for. So for that to happen, we need our x and dy dx to have a coefficient of 1. So I'm going to divide by x squared. So dy by dx plus x cot x plus 2 divided by x squared, which is going to get rid of one of them. So I'm going to have x on the bottom times by y, and that's going to equal 4 sine x over x squared. This is now in the required form because we need to get in the form dy dx plus p of x times y is equal to q of x, where p and q are some functions. We can now work out the integrating factor, which is the exponential of the integral of p of x. Obviously, you can write it with e, but I prefer to write exponential just to give myself more space to do the workings. So our p of x is just everything that we are multiplying y by. So that's x cot x plus 2 over x dx. Now, in terms of trying to actually work this out, I think it's going to be better to split this one up into two terms. So x cot x over x would just be cot x plus 2 over x dx. So we need to integrate cot x, and so 2 over x is a simple log 1. Cot x, should probably be familiar with at this point, so remember that cot x is the same as cos x over sine x. And that sine x differentiates to cos x, so this is going to be a log modulus of sine x. So let's get that in there. So exponential, always integrating factors, we're going to see some sort of exponential, so it cancels normally. It's like not all the time, but in a lot of cases you will. So we're going to have log modulus of sine x plus 2 log modulus of x. Don't need the plus c because it pops out as just a constant that we times by, so it doesn't really matter. The modulus here don't actually matter as well because we're told x is positive and less than pi. So I can write this as exponential of log, and then from our log rules, this is going to come up as x squared, and then we'll times these together, so I'd get x squared sine of x. So like I say, this is going to pop out to be x squared sine of x, which because of the region that we've got, x between 0 and pi, this just pops out as x squared sine x, which is our integrating factor. So we then multiply our equation by the integrating factor, so I get x squared sine x times dy dx. So when I say the equation, I mean the one after we've done the division, plus x cot x plus 2 over x times x squared sine x y is equal to 4 sine x over x squared times x squared sine x. So what do we get from this? You could worry about expanding all the stuff on the right, but you can just remember that it is the derivative of the yif, so y times your integrating factor, so it's the derivative of x squared sine x times y. Would be good practice to check that, but if you're stuck with time, then don't. But I will do just here for the sake of the video. So we're going to have, what's this going to be times there by y, so I'd have, because that's cos over sine, so x's would cancel, so I'd have cot x plus 2 all times by x squared sine x. Now remember, cot is cos over sine, so that's cos over sine. So that's going to give me x squared cos x, and then the sine x will cancel, plus 2x squared sine x, which that's exactly what happens when you differentiate that. Sounds good. Well, wasting a bit of my time there checking. And then x squared is going to cancel, so I'm left with equal to 4 sine squared x. So I know that x squared sine x times y must therefore be equal to the integral of 4 sine squared x. Now, remember, we need to integrate sine squared, we need to look at double angle formula. So cos 2x is cos squared x minus sine squared. And then that's going to become 1 minus 2 sine squared when I substitute in that sine squared is 1 minus cos squared. So then to get my sine, 2 sine squared is going to be equal to 1 minus cos 2x. I've actually got 4 sine squared x, so that's going to be equal to 2 minus 2 cos 2x. So then that's going to equal 2x, and then cos is going to integrate to sine, so that's going to be sine 2x, and then I'm going to divide by the 2, so actually I'm just going to get that. And then just need to rearrange that for y, so y is going to be 2x minus sine of 2x plus c, all divided by x squared sine x. Okay, quite a nice 8 marker there. It's in the form y equals f of x, so looking good to go.